Okay, so I just go then. So thank you, Brett. So good morning, everybody. This session will talk about disaster recovery and continuous availability solutions on IBM Z provided by GDPS and more specifically GDPS multi-site solutions. So first, let me introduce myself. My name is Anthony Morales. I have been working for IBM for 11 years. As you can probably guess by my accent, I am located in France and more particularly in the south of France, in Montpellier. I am a member of the GDPS Development Lab, and my primary role is team leader for the GDPS interface development, including the GDPS graphical user interface and GDPS REST API. And I am also the co-team leader of the GDPS Metro solution development team. So during this session, I'll start by introducing the general concepts of GDPS and give an overview of the business requirements that the solution address and give you an overview of the GDPS solutions that are available and the benefits for each of them. We'll first have a look at the GDPS two-site solutions. Then we'll dig a bit deeper into the subject of GDPS multi-site solutions. That is to say, GDPS 3 and 4-site solutions, actually. So this solution combine metro and extended distance solution. Then we'll spend some time talking about logical corruption protection. Some of you may have heard about the IBM Cyber Vault offering, and LCP, Logical Corruption Protection, is a key component of this solution. So we'll have a look at how LCP fits into the different GDPS topologies and what are the different business needs that it addresses. So first, what is GDPS? And actually, before even talking about GDPS, let's have a look at the different scenarios that drive the need for a disaster recovery and continuous availability solution. So of course, for many companies, IT is an essential part of the business, and data and operation must remain available 24/7 and must be recoverable. It is important to mitigate or even eliminate the impact of disruptive events for your IT. And this event could be, for instance, maintenance, such as hardware or software update, data center switch, test, and so on. And these operations must be transparent and do not disrupt the business operation. So how to achieve them transparently, how to reduce the risk of introducing new issues during a maintenance scenario, that's of course the main challenge. There are also local disasters that could cause damage to a specific piece of hardware or software, such as a disk failure, a system failure, and so on. That could also be an issue affecting your local infrastructure, such as a fire or a power failure. And in such case, could we avoid downtime and data loss? And if the disruption cannot be avoided, what procedure are you using to recover from such disaster? Global disasters are also part of the risk that could cause IT operation interruption, such as major climatic hazards like hurricane, earthquakes, and so on. That could be more or less likely depending on the region where the data center is located, of course. In this case, it's important to have a safe backup of the data outside of the affected region and also procedures in place to be able to recover the operation safely and quickly away from the affected data center. And finally, new kinds of threats have emerged in the past few years in the scope of data corruption, malicious attacks, ransomware, human error, or system issues could corrupt your data, and it could be difficult as part of the recovery process to identify and exploit the most recent non-corrupted version of the data. Plus, it's important, once again, to have predefined procedures to be able to recover from this uncorrupted version of the data. So for all these scenarios, GDPS offers different solutions to mitigate or even eliminate the impact of such event. And this is mainly what we will discuss in the next few slides. So what is GDPS? GDPS stands for Geographically Dispersed Parallel Sysplex. It was initially provided to offer disaster recovery and continuous availability for IBM-Z environment, and it has evolved over the years since its first release more than 25 years ago to extend the scope of the scenarios and the use case that it covers. GDPS is designed to manage and automate your CADR capabilities on IBM-Z. So CADR for continuous availability and disaster recovery. It offers a single point of control for your CADR capabilities and allows to manage ZOS systems as well as distributed servers running on Z, such as Linux on Z, Linux on ZVM, Linux on KVM, IDAA or secure service container, and so on. Data replication is an important part of a CADR solution, and GDPS also offers a single point of control for managing your replication infrastructure. It leverages the existing replication protocols, whether it is synchronous or asynchronous, and offers an automated way of managing them. It also provides real-time monitoring and alert to prevent disruptive events and actually prevent them from being disruptive before they even occur. In case of a failure scenario, such as the ones that we just discussed in the previous slides, GDPS also have built-in automation to react to them and mitigate or again even eliminate the impact that could cause that it could cause on your IT environment. For instance, the hyperswap technology that is driven by GDPS automatically swaps the IOs to the secondary disk in case of a failure on the primary disk. This is all automated, detected, and triggered by GDPS, provided that you have enabled it from the GDPS policy, of course. GDPS also provides automation for planned or unplanned outage through user-defined scripts. So this is a very key point of GDPS, and this is where we have all the automated procedures that I talked about on the previous slide. You can plan in advance for what procedures would need to be applied to your IT environment in case of a planned or unplanned outage by defining GDPS scripts to be executed in such event. Then should an outage occur, all the procedures are already in place in GDPS, and you can execute manually, or they can be automatically triggered by GDPS. So you can execute this script that would apply to the given scenario. GDPS supports multiple kinds of data center topologies, going from single-site topologies with a single data center to a four-site topology across multiple regions separated by unlimited distance. GDPS also allows to automate the capacity provisioning of your machine, which is also important during a disaster recovery scenario. In case of a data center switch, for instance, you may need to lower the capacity on the machines residing on the failing data center and activate more capacity on the recovery data center through the usage of CBU or COD or flexible capacity, for instance. And GDPS allows to automate all of that, and you can define such operation in the GDPS scripts. So as we just discussed, GDPS is an orchestrator for your CAGR operation, and it relies on already existing automation and replication products. So in terms of automation, it leverages system automation for ZOS, NetView for ZOS. For distributed server, it also uses system automation for multi-platform. And in some GDPS flavors that we will discuss a little bit in this presentation, actually, it also uses multi-site workload lifeline. On the replication side, GDPS supports several replication technologies implemented by the disk subsystem, such as Metro Mirror, which is also known as PPRC, or Global Mirror, which are protocols that are available on the IBM DS8K family. So those protocols are also available on other disk vendors, actually, but to get the most out of the GDPS solution, they are really designed to work perfectly with the IBM DS8K family. Note that it also offers solution for tape remote copy. So you can have remote copy of your tape environment that reside on the GS7700 family. So in terms of replication, some GDPS flavors are based on software replication rather than hardware replication. And again, we will discuss this a little bit, but this is not the main focus of this presentation. And this software replication is provided by IBM InfoSphere data replication, which support DB2, IMS, or VSAM data. So on the right-hand side of this chart, you can see the different GDPS solutions that are suited for different types of data center topologies and that address different kind of requirements. So the first one in the list here, GDPS Metro Hyperswap Manager, is a single data center solution that offers continuous availability for ZOS systems. It leverages the Hyperswap technology to offer continuous availability in case of unplanned disk subsystem failure and offers an RPO of 0 and RTO of a few seconds. So just making a side note here for those who need more explanation about the concept of RPO and RTO. So these are metrics that measure the objective in terms of availability. So the RPO, the recovery point objective, defines the amount of data that you can afford to lose in case of a DR scenario, for instance. So the Hyperswap, the GDPS Metro Hyperswap solution offers an RPO of 0, which means that you have no data loss with this solution. The RTO, recovery time objective, is an objective in terms of availability of the application. So how much time can you accept in case of an outage? How much time can you accept your application to be unavailable, let's say? And in case of the GDPS Metro Hyperswap Manager, this RTO is about a few seconds. Then the next one in the list, GDPS Metro Single Leg, is a two-site solution for data centers separated by metro distance. So it offers continuous availability with the Hyperswap protection and also offers automated procedures for disaster recovery scenarios locally, so on the metro area. So it also achieves an RPO of 0 and an RTO of a few seconds up to about an hour, depending on the scenario and depending on the size of the configuration. So because it covers more scenarios than the GDPS Metro Hyperswap, for those scenarios that are covered by both solutions, you will get an RTO of a few seconds. But for the other scenario that are only covered by GDPS Metro Single Leg, you could get an RTO higher in case of a disaster recovery scenario, for instance. Then the next one in the list here, GDPS Metro Dual Leg, offers the same continuous availability and disaster recovery capabilities across 2 sites within a metro region, but allows to manage 3 synchronous copies of data when GDPS Metro Single Leg only allows to manage 2. In terms of RPO and RTO objective, it offers the same capabilities. Then we have GDPS Global GM, which is a 2-site solution for data centers separated by extended distance, potentially unlimited, provided that the necessary connectivity is in place between the 2 sites. So this is more a disaster recovery solution rather than a continuous availability. Because of the extended distance, this solution relies on asynchronous data replication as opposed to GDPS Metro, which relies on synchronous replication. And this is why the RPO achieved by GDPS GM is not 0, but represent a few seconds worth of data. Again, depending on the workload that is running on your disk. But yeah, that's measured in seconds. Depending, again, on the size of the configuration, the RTO varies from a few minutes to up to an hour. Then we have the GDPS Metro Global GM solution, which is actually the ones we will discuss more in this presentation. This is a combination of GDPS Metro and GDPS Global GM, and it offers the advantage of both solutions with continuous availability and disaster recovery on a local region and disaster recovery at extended distance. So we will see in a few slides how it is implemented and what solution it offers. And this solution exists for 3 and 4 site topologies. Then the next one, GDPS continuous availability, is a solution that offers continuous availability at extended distance. So this is a completely different solution that the other I just described, because unlike other GDPS offering, this one relies on completely different technologies. It relies on software replication rather than hardware replication. And in terms of availability, in terms of continuous availability, actually, it relies on what I mentioned earlier today, multi-site workload lifeline, to provide workload balancing between 2 sites at extended distance. So this is not the same technology as hyperswap, which is implemented in the GDPS Metro solution. And by the way, there is another session about this solution this week during the GSE. Finally, the GDPS virtual appliance is a built-in GDPS Metro solution that is prepackaged and that is intended for non-ZOS customers. So historically, and as I said earlier, GDPS Metro is designed to manage ZOS systems, and actually the GDPS controlling system that goes along with the solution to manage the environment are themselves ZOS systems. But some IBM Z customers that use only distributed systems, such as Linux on Z or Linux on ZVM, does not necessarily have the skills to maintain a ZOS environment. And this solution is targeted to them, where we basically offer them a prepackaged black box that they just deploy on their IBM Z. So they just install an image on an endpoint and run it out of the box. And it offers the same continuous availability and disaster recovery capabilities as GDPS Metro, but for Linux on ZVM systems without having to manage the ZOS environment. So if you have any questions, don't hesitate to interrupt. So this chart quickly to show that GDPS is actually a largely adopted CAGR solution in the mainframe ecosystem. So at this point, we have more than 1,200 licenses that have been deployed since its creation in 1998, and it keeps growing over the years. So all of this to say that this is an improved solution. This is something that is largely used by customer in the mainframe ecosystem, and that it has been used for several years. And if we take a closer look at the multi-site solution, so the GPS Metro Global that I just described earlier and that we are going to focus on during this presentation, those are more recent solution, but still the adoption is quite important. As it stands, we have 65 customers that are using GDPS Metro Global Free Site, and we have 24 that use GDPS Metro Global Foresight. Also, a large interest is growing among our customers and among potentially new customers, actually, for logical corruption protection solution. So 87 LCP features has been sold just in the last 4 years, and we expect these numbers to continue growing given the threats that cyber attacks represent. So we see a very big trend in the cyber protection area. So before deep diving into the GDPS free and foresight solutions, let's have a closer look first to the GDPS two-site solutions. So GDPS Metro is a two-site solution for data centers at metro distance. That is to say, separated by less than 200 kilometers. At least that's what the chart says. In the real world, that's a very big number, and that's really the maximum that you can achieve in some particular configuration. But in the real world, to take all the advantage of a GDPS Metro solution, this would be more about 100 kilometers or less. This provides continuous availability and disaster recovery within the metro area. It relies on several underlying technologies and allows to automate your CA and DR procedures. So among the technologies that it relies on, there is the Sysplex, a GDPS metro environment, manage ZOS systems in a Sysplex. So it allows to manage this system and control them in case of a DR scenario. You can, for instance, shut down the system on the failing site and re-IPL them on the secondary site, and so on and so on. Note that even if GDPS Metro relies on the Sysplex and that the GDPS Metro controlling system are in this Sysplex, GDPS can also manage ZOS systems that are outside of the main Sysplex, let's say. So that there could be a standalone system or systems inside another Sysplex. And it can also manage distributed systems, as I mentioned earlier, such as Linux on Z, Linux on ZVM, Linux on KVM, and so on. In terms of Sysplex, GDPS can also automate the operation for the Sysplex itself. So for instance, it manages the coupling facilities, the coupling dataset, and it allows to automate all the related operation during a planned or an unplanned DR scenario. Another underlying technology is the Metro Mirror Replication Technology, also known as PPRC. This is a synchronous replication technology that allows to keep in sync 2 copies of the production data. And GDPS Metro allows to simplify the management of the Metro Mirror, and more importantly, extends the data consistency provided by Metro Mirror to the entire environment. Because of the synchronous nature of the protocol, GDPS Metro allows to have no data loss. And so this is why you can achieve an RPO of 0. Next important technology that is leveraged by GDPS is the hyperswap technology. So this technology allows to transparently swap IOs from the primary to the secondary site in case of the failure on the primary disk subsystem. This is done automatically by GDPS when it detects the failure on the primary disk, again, provided that you have enabled it in the policy, or it can be done manually using a GDPS script during a maintenance operation, for instance. If you have to apply maintenance to your primary disk subsystem, you can leverage hyperswap to swap to the secondary, apply your maintenance on the primary, and then go back when the maintenance is finished. As I already mentioned earlier in this presentation, GDPS Metro exists for single leg or dual leg configuration. The GDPS Metro dual leg configuration allows to have two synchronous replication legs. So it extends the hyperswap capability on both replication legs. In case of a primary disk failure, the hyperswap can take place on either leg. After hyperswap, and until the primary disk failure is resolved, hyperswap remains enabled on the remaining leg in case of a new disk failure. So this is the extra protection offered by GDPS dual leg compared to single leg. If you have a failure on one disk, you still have hyperswap protection on the remaining leg. So as you can see on this slide, they are on the right side, you can see the Metro dual configuration. There are two synchronous replication legs, which mean that the primary data is copied synchronously to the two secondary targets. In this case, RS2 and RS3. The remaining leg that we can see here between RS2 and RS3 is what we call the incremental resync leg. It means that it can benefit from the incremental resync capability to resynchronize mirroring between RS2 and RS3 without having to do a full copy. So let's imagine that the systems here are running on RS1. So the application used the RS1 disk. RS1 is replicated to RS2 and RS3. In case of a failure of RS1 disk, hyperswap will take place on either RS2 or RS3. So it depends actually on the policy that you have set up in GDPS regarding your preferred leg. And for the sake of the example, let's say that it's swapped to RS2. Once the hyperswap is done, the system, because of the hyperswap technology, the system can transparently continue doing IOs to RS2, and the mirroring can be resynchronized from RS2 to RS3 without having to do the full copy because of the incremental resync technology. So only the modified tracks of RS2 will have to be copied to RS3. In terms of disaster recovery capabilities, syspec management, and system management, GDPS single leg and GDPS dual leg offer the same capabilities. So we just talked about two-site solution at metro distance with GDPS Metro. GDPS also offers two-site solution at extended distance, and this is GDPS Global GM. GDPS Global GM relies on the asynchronous replication protocol, Global Mirror, or GM. It does not provide continuous availability with hyperswap because of the constraint imposed by the distance. And this is more a disaster recovery solution that provides automated procedures to restart production systems and application on a disaster recovery site in case of a failure on the primary, or if you need to do tests or DR exercise and so on. So this protects, again, complete site failure and major disaster that spread across an entire region. Finally, because of the asynchronous nature of the GM protocol, this time the RPO is not zero, and a few seconds of data could be lost in case of a site switch. Again, depending on the size of the configuration, and depending on the workload and so on, the RTO can be from a few minutes to up to an hour. Okay, now that we have seen what GDPS provides in terms of solutions across two sites, let's now have a deeper look at the multi-site solution. So what we call multi-site solution actually is 3 and 4 site, even though two site is multi-site, but yeah, if you hear multi-site solution within the GDPS context, it refers to GDPS 3 and 4 site solutions. So you may ask, why do we need more than 2 sites? This is simply to fulfill the requirements of many of our customers, requirements that are mainly imposed by auditors and regulation that need both the advantage of GDPS Metro and GDPS Global GM. So this offers local continuous availability with hyperswap on the local region and disaster recovery at extended distance. So this picture on the slide shows a production data center in Portland, Oregon, with 2 sites, A and B. Site A is the primary site. This is where the system IOs go, and synchronous replication is made from A to B. So this is a classic GDPS Metro environment. But then we can see that we have another data center located in Atlanta, so which is far away from Portland, with 2 sites, C and D. And the data in B is asynchronously replicated to the other region to C, which is itself replicated to D. So we can also see, by the way, in this picture that we can use incremental resync from A to C across the region. So basically, the main concept is that we have local protection and continuous availability in case of a local failure in site A or B in the primary region. And we have extended protection outside of the region in case of an entire region outage in Portland. So that's the base concept and the idea of why we have Metro Global. And now let's discuss the different solution, the different implementation actually that you can make with GDPS. So GDPS Metro Global GM is available in 3 or 4 sites. The GDPS Metro Global 3 sites provides local continuous availability with GDPS Metro on the production region, A and B that we can see here, and disaster recovery at extended distance with global mirror between the production region and the recovery region. So note that the global mirror session that you can see here can be from B to C, so in a cascaded configuration, A, B, C, or can be from A to C in a multi-target configuration, A, B, A, C. In fact, all the replication combinations are possible, and we'll see that in a few slides. So we have hyperswap available on the production region in case of a primary failure. And in case of a complete site failure, GDPS allows to recover and restart the production on the recovery region. Now, once you are running on the recovery region, the issue in this particular configuration, and actually this is fine for many customers, but the issue is that you don't have the continuous availability capabilities on the outside region. You don't have hyperswap. Again, this is fine for some customers, but some customers require the same level of availability on the 2 regions, which is the reason why GDPS also supports 4-site configuration. So for customers that require to have continuous availability on the recovery region, or customers using a DR cloud model, for instance, and that need to switch regularly from one region to another, GDPS Metro Global 4 sites offers a symmetric configuration with the same infrastructure in both regions and the same level of availability. So let's take the example of a customer that is running 6 months on a data center and 6 months on another data center, which is located in another region. GDPS allowed them to automate all the procedures and operation required to make this region switch. So when running on either region, the local GDPS Metro implementation offers continuous availability with HyperSwap and all the automation available in the classic GDPS Metro solution, actually, the local DR, the sysplex management, the system management, and so on. And then when they need to switch region, they can use GDPS to automate all of this. So GDPS provides built-in procedure for performing the required task on both regions. So stopping the LPARs on the production region, restarting them on the secondary, managing the replication, activating capacity on the new region and deactivating on the primary, and so on and so on. So this is automated by GDPS. As part of these procedures, you can also include user-defined procedures as part of this operation if you have specific operation that you need to run on your environment. So, as mentioned earlier, GDPS Metro Global support cascaded or multi-target configuration. And this actually can be dynamically switched from one configuration to another. Why this is important? Because for several years, GDPS Metro Global only supported cascaded configuration. But for a few years, now, GDPS does take advantage of the multi-target capability of the disk subsystem. It's important in some scenarios to avoid suspending the GM relationship, as we will see on the next slide. So let's suppose that we are running in a cascaded configuration, A to B to C, and that we have a primary failure on A. So HyperSwap will swap to B, and we now run B to C. You can also see that the mirroring up to this point, the mirroring from A to B is suspended. Not that it's suspended, it's not deleted, which means that when we are ready to resync B to A, we won't have to do a full copy from B to A. There is a mechanism that keeps track of the update on B, and only the delta between B and A will have to be copied. So once A is back, we can resync mirroring from B to A while keeping the GM replication from B to C. And this is because of the multi-target support. Because before this support, you would have to suspend the GM replication from B to C, then resync B to A, and then resync A to C, or hyperswap back to A to be able to resync B to C. So it left a window where you lose your DR protection. But this is not the case anymore thanks to the multi-target support. Also note that we also have the incremental resync capability between the two regions. So if I'm running BA, BC, and if for any reason I wanted to switch back to a cascaded configuration, BAC, for instance, then I can benefit from the incremental resync to allow me to resync from A to C without having to do a full copy. So to summarize, in the MGM free site environment, all the replication combination are acceptable. You can have a BC in a cascaded, or you can have BAC, or you can also have any multi-target configuration, ABAC or BABC. So to summarize, the GDPS Metro Global GM Solutions 3 and 4 site offers local continuous availability with HyperSwap and disaster recovery outside of the region. The main important thing is that GDPS provides automated procedures to be able to automate the region switch. And among other things, to do that, you can use something that is called the procedure handler. So this is something that is relevant to GDPS Metro Global Solution only. So you have procedure script statements that you can use to automate the region switch and all the operation that it implies. And GDPS has intelligence to be able to know from which position it starts, to be able to know what actual operation needs to be done, for instance, on the replication management and so on. So it's not the same thing if you want to do region switch from a cascaded environment or for a multi-target environment. You won't have to do the same operation in terms of resynchronization of the data and on the global mirror session and so on. So GDPS determine all of that automatically with thanks to the procedure handler. So at this point, we have seen all the GDPS 2-site and 3 and 4-site configuration that are available. And as mentioned earlier, GDPS provides logical corruption protection on top of this configuration. So let's have a look at the concept and the functions of GDPS in this area. So the introduction of LCP, logical corruption protection, came from new requirements that are driven by the new threats that are rising in the IT ecosystems, such as the ransomware attacks. So our customers need to increase their security capabilities to protect from malicious or involuntary data corruption, such as corruption introduced by privileged user, whether it is voluntary or involuntary. This could be caused by human error, and this can be unintentional, but still that could cause corruption. So there is an example where a few years ago, an IT employee who has been fired set up a time bomb in the company system before leaving the company. So when it triggers, after he was gone, it encrypted important data. And yeah, if you don't have a data corruption policy and procedures, it can be difficult to recover from this kind of things. So to achieve this security goal, the client needs to be able to take regular, secure, and space-efficient point-in-time copies of their data to be able to recover from it in case of a data corruption. So we'll see in the next few slides that LCP is enabled thanks to functionalities provided by the storage, the operating system, the middleware, and so on, to enable the different use case for the LCP scenarios. So we'll see what GDPS provides in terms of LCP support for the different topologies. So to illustrate the concept of LCP, let's first have a look at a data corruption scenario in a classic GDPS Metro environment without LCP. So we can see that this configuration is a classic GDPS Metro configuration. It has 2 sites with synchronous replication. We also have a flash copy that is taken on each site. So this is a capability that was already available on the classic GDPS Metro environment, even before LCP. But with a classic, you can only take 1 flash copy at a given time. And you can only have one flash copy that is managed by GDPS. So we have systems running IOs on the primary site, and the data is synchronously replicated on the secondary site. Now imagine that we have a cyber attack or an intentional mistake that provokes data corruption on the primary disk. So what will happen? Metro Mirror will just do its job and copy the corrupted data over to the secondary disk. So great, now we have 2 corrupted copies of data. The only usable data that we have at this point is the one that is on the flash copy, but is it really usable? Was the flash copy taken before or after the corruption occurred? How old is it? If the flash copy was taken 2 days or 1 week ago, does your business can afford to restart from a 1 week old copy? Probably not. So now is an example of the same data corruption scenario in an LCP environment. So we still have a GDPS Metro single leg environment with primary disk being synchronously replicated to the secondary site. IOs goes to the primary site, but now we have an LCP environment, and thanks to that, we are taking point-in-time copies of the secondary disk every 15 minutes. Side note here on this chart, the point-in-time copies are taken using flash copy, but LCP also supports safeguarded copy, which allows to take more copies than the flash copy implementation. So now we have GDPS managing and automating flash copies every 15 minutes. So we take a first flash copy at 1:30, then 15 minutes later, we take another one at 1:45. And at this time, the data is still good. Now, 5 minutes later, we have a data corruption that occurs at 1:50. And it may take time to identify that the data has been corrupted. And until then, the systems may continue to run and the corruption may not be detected right away. By the way, another side note here, this capability to detect data corruption is one of the item that the GDPS team is working along with the cyber team. So we plan to provide enhancement to GDPS to be able to detect such kind of corruption. So the corruption being undetected for now, we just continue to run with it, and we take another flash copy as planned as 2 a.m. Of course, this flash copy is not good because it contains the corrupted data. Then we take another one 15 minutes later at 2:15. And finally, at 2:20, we notice that something is going on and that the data is corrupted. Because of LCP, we now have a good copy of data to restart from that was taken at 1:45. Again, here, this might take some time to identify which of the copy is the good one to recover from. And this takes some analysis. So as part of the LCP infrastructure, you can see on this slide here that you have an RC1 volume, which is the what we call the recovery copy. So you can recover your point-in-time copy in this recovery volume. So the recovery process is automated by GDPS. So you can take one of the copies, recover it to the RC volume, and start your system on this RC volume to do forensic analysis and determine what is corrupted and what is the point-in-time copy that is good to restart from. Again, all this validation that is a bit manual is also something that GDPS is working on. So we have an item ongoing to be able to automate the validation. So whenever we take a copy, we are working on mechanism to be able to validate that the copy is good, and you will see the copies that are flagged as good or the ones that are flagged as corrupted. So instead of you having to manually validate that, GDPS will do that for you in the background. So now that we have identified our last good copy, we can, with GDPS automation, restore this data into our production volume. Okay, another important concept here is that GDPS offers different topologies for LCP, and that there are two main models that we are going to discuss here. Virtual isolation versus physical isolation, also referred to as virtual air gap and physical air gap. This is also terms that you could see in the GDPS concept. So virtual isolation is an environment where your LCP infrastructure is shared within your already existing GDPS solution. So the disk subsystem used to take the point-in-time copies are the same that are used for your already existing production environment. Also, the GDPS controlling system that manages your LCP environment is the same as the one managing your GDPS solution. So in case of GDPS Metro, that would be the GDPS Metro controlling system. In the case of GM, this would be the GM controlling system. Also, the storage subsystem are in the same network area as your production environment, because the copy are taken from the same disk subsystem actually. Now, a physically isolated environment is completely separated. There is a dedicated LCP infrastructure outside of your production environment. So the point-in-time copies are taken on a separate disk subsystem, which is, well, on separate disk subsystems. There could be one, there could be more, which are isolated from the production environment. And in this case, also the GDPS LCP manager, that is the system that manages your LCP environment, is also separated in that LCP isolated infrastructure. So because of that, you can restrict the access to the LCP environment and better protect from malicious attack, whether it comes from the inside or the outside. Now, I have a few minutes left, so I'm going to show you a list of the LCP environments that are supported by GDPS. This is not an exhaustive list because I want you to focus more on the multi-site solution, but it gives you an idea of the kind of implementation you can make with LCP on different GDPS topologies. So this is a GDPS global GM with a virtual isolation. So we have a classic GDPS global GM solution that offers disaster recovery at extended distance. And off of the secondary disk on the recovery region, we have an LCP environment. So the point-in-time copies are taken from the same disk subsystem as the secondary global mirror disk, and the LCP feature is managed by the GDPS Global GM remote controlling system. Now, this is a GDPS Global GM solution with physically isolated LCP. So this time, the LCP environment is not directly implemented on the secondary global mirror disk. There is a global copy session that makes a copy of the RS2 data into a separated environment. Of course, it means requirements for additional disk subsystem, additional CPU for the recovery sysplex. And this global copy is managed by an external GDPS LCP manager that control both the global copy from RS2 to RS3 and the LCP environment. Another example with a GDPS Metro dual leg with external LCP. So this is the same concept here. We are taking a copy of the production data off of RS3, but since this is a GDPS Metro environment on the production region, this time we are taking this copy with global mirror instead of global copy. To make the copy to the separated environment, and both the global mirror and the LCP environment is controlled by a separated LCP manager. On this slide, we see a GDPS Metro global mirror free site with external LCP, so physically isolated. Again, a copy of the recovery site is taken with global copy on an external location and managed by an external LCP. And finally, this is the same configuration with MGM free site, but this time with virtual isolation. So this time there is no global copy of the recovery region disk. The LCP capture are taken directly from RS3, and the LCP environment is managed by the GDPS remote controlling system. And finally, this is one of the most complex solutions that we can have. This is a GDPS Metro Global GM foresight with external LCP. So we have a MGM foresight environment with RS1, RS2 on local, global mirror from RS2 to RS3, and then GDPS Metro on the other region between RS3 and RS4, and then a global copy to another external location to manage our LCP. So as a conclusion, if you have to take something out of this presentation, it will be that GDPS multi-site solution provide continuous availability and disaster recovery at extended distance, and local protection in your primary region. It offers local CA and protection from regional disaster. It offers built-in automation for recovery procedures. This is one of the key points of GDPS. And it can implement the LCP feature, whether virtually or physically isolated, to protect from data corruption caused by ransomware or any other data corruption events. So if you need more information about GDPS and Cyber Vault and cyber resiliency, you can check those links. If you need to contact the GDPS team, you can send an email to gdps@us.ibm.com, or you have my email at the beginning of this deck. If you need to ask me any technical questions, I'll be happy to answer. So thank you, everybody. And if there are any questions, I'd be glad to answer.
Anthony, there's one question from Peter Lezek. How much penalty does synchronicity impose on IO in the case of Metro Mirror, especially on batch, if we consider 100 kilometers distance locations connected via FICOM?
Yeah. There is, of course, a penalty. It's not that much because many of our customers are running in a GDPS Metro environment. But you are right, there is a penalty. It's negligible. Here we are talking about 100 kilometers. Yeah, the more the distance, the more the penalty will be painful. But actually, in terms of distance, and especially in multi-site workload configuration, the more penalty that you will get is regarding cross-site connectivity for host to disk and for sysplex communication, actually. So the penalty imposed by the replication is not the worst, let's say. So when you consider setting up a metro environment and when you consider the distance, the more penalty that you would get is regarding the sysplex connectivity rather than the FICON connectivity and the penalty imposed by the metro replication.
Thank you. Is that okay, Peter? Is that okay, Peter? Okay, perfect. Thank you very much. Thank you. Thank you, Anthony. Okay, it's 11:31. I don't see any more questions, so please send your feedback. I enjoyed that presentation, and maybe see you all in the next session at 1:30, where we have yet another live demo. So that could be interesting. Thank you very much indeed, everybody, for attending. And thank you very much, Anthony. Enjoyed that.
Thank you.